just getting straight into it, what is a JavaScript engine? So you might know V8, which Chrome makes and produces, Safari makes JavaScript Core, Firefox makes SpiderMonkey, Node and Dino, the server-side JS runtimes, they use Chrome's V8, Bon uses JavaScript Core. You can mostly think of them as the same. There's no major differences, it's kind of preference. But how do they actually run JavaScript? So Quick.js is probably one of the most well-used JS engines, which no one has heard of. Which it's mostly used in programs which they want to run JS, but they don't want like 80 megabytes of a browser running it. So interpretation is just, you have a program, it runs the JS in a loop internally. So just-in-time compilation, which V8 basically made famous, is instead of just running that in the program, you compile it to machine code on the user's machine, which can get you great performance. Yeah, so it has much better performance, but then also you have that slower load time of you need to actually compile that code to machine code. The security can be questionable. Like, I think I didn't have any actual numbers, but probably like half of browser security bugs are due to JIT issues. And yeah, you need a lot of resources to actually do that compiling. So yeah, most browsers nowadays work by having several different just-in-time compilers, one which will be really fast at compiling, but then not that fast at actually running it. And then as a function is used more and more, it will then use that higher JIT tier. So ahead of time compilation is what other more traditional native languages use, like say C++ or Rust. You give that to a tool like Clang, it just dumps out a binary on the developer's machine. It fixes most of these trade-offs. You get faster execution because you're compiling it. You don't have that slower load time because you're compiling on a developer's machine. And security isn't concerned because, again, all of this is on the developer's side rather than the user's. So compiling JS to WebAssembly is slowly being used today, mostly because you get free sandboxing and security wins, and a lot of things are increasingly just taking a WASM binary as input, and you have to have a WASM binary. So today, most things just bundle Quick.js, the interpreter, into WebAssembly, which is great because it runs like all JavaScript, but you have basically terrible performance because you're already interpreting, and then running that in WASM just adds more overhead. And also, it means the WASM binary is very large comparatively. And then you can also, compiling JS to native is nice because you just get a one-click executable. You don't have to tell your users to install Node or something. And typically there is a resource usage and performance win if you do it well. So if only you could ahead of time compile JavaScript like this, which is what Porffor is. So going back to the diagrams from earlier, this is where it kind of fits in. And I will now do a demo. So say I make a little JavaScript script, like just a basic hello world, and then I want to compile it to a native binary. So I just run Porffor here, and it just runs, and it's 20 kilobytes. Or you could say, just compile it to WebAssembly, and yeah, and that's about 4 kilobytes. So yeah, it can also support TypeScript because you can control the entire JS engine. So why not also add TypeScript support? Yeah, the architecture oversimplified looks like this, which is you just take in the JS source code, pass that into a syntax tree, compile that to WebAssembly. Less simplified is you can then also take that WebAssembly, compile it to C, and then give that to any C compiler to get a native binary without having tons of like maintenance burden. Yeah, less simplified. There's a lot of work into optimization because performance is important. So yeah, the main downside is you have to reinvent the entire JS engine, which is a lot of effort and time. Some things are much faster, some things are slower. So test 262 is the official test suite for the JS specification made by people who write it. And currently, Porffor passes about just over 58% of the entire spec. So that's everything from like basic math to temporal or newer emerging specifications. And yeah, and it's just on GitHub if you want to play with it. And you might also be surprised it's written in JavaScript and TypeScript. It's not some like C++ behemoth, which is very hard to contribute to or maintain. Like, here's an example of some code, which hopefully is pretty readable, just normal TypeScript. But this is the code the engine actually uses under the hood. So yeah,